It's really a delicate dance between many factors that are driving both the onset of the fall foliage as well as the intensity of the color that we see. Basically, what happens is that the trees sense the onset of winter as the contrast between daytime temperatures and nighttime temperatures increases, and as the length of the day shortens. As they sense that onset, they begin shutting down, and they try to reabsorb as much of the energy that's stored in leaves as possible. These are sugars and carbohydrates that the trees have been producing all summer long. And as this is happening, the chlorophyll in those leaves, chlorophyll is catalyst for photosynthesis, and important for all of life on Earth. It makes vegetation appear green to our eyes. The chlorophyll is beginning to degrade. And as this happens, it reveals other chemicals that have been in the leaves all summer. So these are the same chemicals that you find in bananas that make them appear yellow and in oranges that make them appear orange. At the same time this is happening, the trees are trying to buffer those leaves and hang on to them as long as possible so that they can absorb as much of the energy stored in those leaves as possible. And to do that, they produce another group of chemicals called anthocyanins. These anthocyanins give us the reds and the purples that we find in some species like maples and oaks, and add a lot of diversity to the color that we see on the landscape. There's pretty good evidence that climate change, especially our warming summers, is delaying the onset of fall foliage. There's even some research that's suggested that the onset of fall foliage may have been delayed by as much as a month over the last century. The other thing is that climate change can dampen the intensity of the fall foliage. And this happens particularly after extreme droughts or after summers like we've just had with really extreme rainfall and wet, saturated soils. So these types of climate extremes create stresses in trees, which can interfere with the production of some of these chemicals that give us color and can interfere with the overall productivity and health of trees. In the Northeast, where I live, our climate seems to be getting rainier and wetter. We think that our rainfall has increased by something like 21% in the last couple of decades. And our winters especially are getting a lot warmer and rainier. So these changes affect tree health, tree productivity, and their ability to produce some of these compounds that give us fall foliage. Can conserve forests by conserving healthy, complex forests, particularly older forests, I might add, that are able to buffer their own climate beneath their canopies. This might help forests resist some of these climatic changes, reducing the stocking or the density of trees to make them less prone to drought. Of course, in the West, all of the various techniques that we use to support and restore natural fire regimes, so things like reducing fuel loading and the use of prescribed burning, all of these things can make our forests more resilient to climate change.